So his name is Benedikt, and he's talking about Hyperdeck.
Bonjour, je suis Benedikt. I will talk about an app that I've been working on for the past more than half a year, 1.5 years, called Hyperdeck. And before going much further, I will basically start the presentation now and go into the slides, and then you hear all about this and what I'm trying to say. Let's see, selecting the right screen, hitting share, selecting the app. Can you see the slides? Okay, perfect. So I'm going to talk about an app called Hyperdeck. You see a brief preview of the app on the left side. It's basically a presentation app that lets you do all the slides with Markdown, but it runs on iPad and on Mac, and it's somewhere in between Keynote and other Markdown apps, in that you also get inspectors to modify and have more flexibility over your slides. The title of this talk really is what can go wrong on a 1 year plus side project, because I will mostly be talking about the problems I ran into, so that you maybe learn from what I experienced also. I'm going to present this with Hyperdeck, so with the current Mac beta, so it might be that some things look a bit weird because this is like not a released app that I'm trying to do these slides with. As I already mentioned, I'm Benedikt. You can see a picture of me there because you don't see me standing there. I don't look like that anymore. That was during the quarantine where I decided to cut my own hair, and I stopped halfway through. You can find me on Twitter like that. That's my name. And I work at a German company called Xing, which is a social network much like LinkedIn. And that's enough about me. Let's talk about the app. And before I'm even going to talk about the app, I want to briefly demo it. I don't want to spend too much time on that, because we want to talk about code and problems and so on, but you still should kind of know what the app is about. I'm presenting this on my iPad because that's where the app is more stable right now. And once you start the app, it kind of looks like this, and I can basically start writing Markdowns. I can say, hey, Paris, and then you can see on the left side a slide appears. I can do a list, say first item, second item, third item. That's kind of easy. I can also insert another list like this, and then basically say, hey, again. And there are lots of keyboard shortcuts to do all these things, more list items. And then I can also select things, and then I have this toolbar at the bottom. I can make things bold, like here, or I can use strike through like this. So I have a variety of things I can do. Once I have this, maybe I want to change something. And now this is where the app comes in, because this is standard Markdown, but I have these inspectors here, where basically I can say for this headline, I want to change the font size. And so the font becomes bigger. Or I want to give it a animation. So I can say this headline should animate in, it should move in. Or I can also select the slide and basically say, okay, I want to change the slide. I want to give it a background image. Let's do that. Let's do that. So I already imported an image beforehand, and now we have this nice beach image in the background. I can also change what the slide looks like. So there are slide masters that allow me to give the slide a certain look. And there's a lot of other things. There are also slide transitions that I can add. And now you might wonder, well, if all this is Markdown, how do you save this information? And for that, I kind of extended Markdown. So as you can see here now, there's this additional syntax that basically has the parameters for these changes. The same for the slide. So here I have parameters for the slides that kind of explains how the slide should transition. And that was important to me because what I want is that you don't have to use the built-in editor. You can use any editor. And with any editor, you should also be able to do all the things that the app offers. Nevertheless, I wanted to be able to use these screens to make it simpler for you, to basically, like in Keynote, modify your slides, but still be able to use the raw Markdown for this. There's also support for a couple of other things, like when I add another slide here, Markdown tables are supported, so I can insert a table here and add some stuff like this. Or I can also, which is much more interesting to programmers, I can add code. So I can basically say here, okay, I want to add code to these slides. Once I do that, I can select the language that I want to use. So there's also the built-in languages. Let's use HTML. And then I can say, okay. And then you get also syntax highlighting for free automatically. Finally, I also added comments as an extension to Markdown, so I can say this, and now I have comments within the Markdown, so that that I have presenter comments that are part of the presentation. Now, once I'm at a certain state where I want to all play it back, before I do that, I can also rearrange the slides. So I can take this slide and move it here, and then it rewrites the Markdown. So basically now in the Markdown, the slides are rearranged because the truth is always in the Markdown. Final thing, if I want to present it, I can hit the present button, play from beginning, and now we can briefly iterate through and see Harry Paris with the small animation, and that's it. So I don't want to talk much more about what the app does, but basically this is the app, and there's, oh, I forgot one thing, there are obviously built-in themes, so I can go in here, I'd say change theme, select themes, and then I can select one of many different themes, basically that allow me to give the whole thing a more interesting look. I'll go back to the slides now. So that was the demo. And the first question you might ask is, why would you want to build a presentation app on your own? And that's a fair question. The problem I had is I do give a lot of talks, and I always used a different app because somehow nothing really did what I wanted to do. That was one of the big problems I ran into. So I tried Reveal.js, which was difficult. I tried Keynote, but code in Keynote is very difficult. I tried DeckThat, but DeckThat didn't have the flexibility that I wanted to have. I had a script that converted Markdown to Keynote, something written in Ruby, but that makes it difficult to edit it once you created the Keynote file. I even tried Emacs, and that was actually one of the better experiences. And so over the years, I came up with a list of requirements because I felt, if you would reinvent presentations today, like from a developer's perspective, that's why I am, what would you do? And the thing is, I feel it should work on iPad and macOS equally. There should be like JavaScript or anything because you want a native app to use a lot of native features. And the editor should be IDE-like. It should understand what's happening on the slides, kind of like Swift Playground, just for slides and Markdown. And maybe expand upon that and have animated themes. You don't really see that right now due to the connection. I disabled them, but themes can have animated backgrounds and so on. So I set out last year from July to August to build a prototype over 2 weeks. And this is something, if you decide to do a project on your own, always start with a prototype. It's great. I had element animations, I had SwiftUI slides, I had a custom Markdown parser to see if what I want to do with my custom Markdown syntax, if all that works. And that was great. This is a picture of the prototype after 2 weeks. So I have on the left side, I have the Markdown, on the right side, I have the slides. That was great. It was also very useful because it validated my ideas about using SwiftUI for slides, and it validated also my ideas about parsing speed and latency, like if it's fast enough, even on an old iPad, to actually pull this off. But what it also did is it gave me completely wrong ideas about the scope of this project, because I thought, well, if I'm already here after 2 weeks, then it will only take 3 months to have a kind of product I could sell. That's not true. Which brings me to building it, to see like where did I lose all this time? Like, why is it still not finished? So let's go into it. First of all, what's important to notice, I do have a day job. As I said in the beginning, I work at Xing, German company. So I only do this in my spare time, evening, morning, weekend. So I already have to make cuts everywhere. There's no full common mark support. It's not really well tested. There are some performance issues. Last year, November, I was on vacation in Tenerife, 2 weeks, great island. And half the time I spent working on this app because I didn't have to work at my day job, right? So I had free time. On the right side, you can see my girlfriend sitting there trying to fill up the time with something else to do because I was busy working while we were on vacation. Looking back with the COVID time now, I shouldn't have done that, but well, that's you can't really reverse time. Some information about the code base. I have now around 1,600 commits. I have 34,000 lines of Swift, 11,000 lines of Rust. And if I add up all the code I deleted to this, I am beyond the 100,000 lines code now. If I take up all the code I also rewrote because changes in SwiftUI and so on. I wanted to give up at least 10 times because things didn't work and things that I thought would work didn't work anymore and so on, but I will talk about that. So let's look into the tech stack, which is a brief explanation of how this works. Fundamentally, you saw the UI. On the left side, you have a UI text view, which is used as the editor. I added a lot of stuff to that to make it a well-working code editor. Then all these inspectors, as I call them, to modify the code they're written in SwiftUI. And then on the right side, you have your collection view with different data sources and composable layout that's responsible for the slides. In the slides, there's UI and some UI labels for enhanced text rendering. And then all the data is the UI document, and the parsing is mostly done in Rust. So Rust parses it back to your document, and then I'm using Combine to move this data back and forth. When I started doing this last year, that was a very heavy tech stack, because if you look at that, it's your SwiftUI, data sources, Combine, a lot of unknown stuff, and then even Rust. So a lot of stuff that was very new, and I paid for that, because these things are buggy and they're underdocumented. Another thing I will be talking about. But briefly, I want to go into a question that you might already have. Why Rust? What is even that? And that is a language very similar to Swift. And I chose that because last year in August, there was no good native Markdown parser in Swift. As you remember, I have these extensions to Markdown, so I needed support for that. And there is obviously CMark, which is the standard common mark parser, but extending C code is not something that sounded right to me, because I'm not very good at C, and I was afraid it would just end up in memory leak. And I could also use the tens of thousands of JavaScript Markdown parsers, because I wanted to do that. But there was a really good Markdown parser for Rust that had support for all the things I needed, and could also do a couple of the things that I needed that are very hard to find. And since I knew Rust, I decided, well, how hard can it be to basically just use a Rust library instead of C library from within the Swift app? Because my requirements were, I just wanted to have a single parsing pass. So when you type something, it should just do one thing, and I would need to have all the information about the Markdown. And I don't, usually a lot of Markdown parsers, they give you HTML or some sort of string representation or attributed strings. I didn't need that. What I needed was a tree of all the elements in the slide, so that I could use them in the editor and in the slide view, in the collection view. I also wanted to have syntax highlighting in the same pass, so that once the slides are rendered, I have all the information I need to display them. And at best, I wanted to do it concurrently, because if you have like 150 slides and you do something, like it shouldn't do one after the other. We have multi-core processors nowadays, that should be possible. And that was something that Rust offered. And here's an example how that works. If I have this Markdown, which is a headline that says hello world, and world is bold. So what I get back from Rust is I get this struct that says there's a headline, and this headline is built out of these elements, a text and the bold with these ranges. And then I can take these ranges, index into the Markdown string, and get the contents out. And this is very fast. There's almost no allocations and so on. It makes it great for me to easily display the things I want. And I can use the same information to highlight the UI text view. I thought I would give a brief example of what that looks like in Rust, like the concurrent parsing and so on. So there's just 2 slides of what Rust code is like. I don't expect you to pay too much attention here. This is not Swift, it's Rust, but I thought it would be interesting. And I'm using something called the Corasick algorithm for that. If you ask Wikipedia, it says the Corasick algorithm is a string searching algorithm that locates elements of a finite set of strings within an input text. It matches all strings simultaneously. What that means is this is very fast. And I need that, because what I'm doing here is I get all the Markdown, let's say 150 slides, and I'm splitting it up into the individual slides, so that I have each slide separately as one block of text, and then I can parse them all at the same time concurrently. And so the way this algorithm works is, if you have BART, and barn, like 3 very similar words, then basically it's optimized for cases like these, for finding words that have slight variations and finding them very fast. So here's the Rust code that does that. This is basically the function header. Instead of func, it says fn. Other than that, it looks very similar. And then I have 2 patterns. The first one is a new line and the 3 dashes, and the other one is a new line and the 3 asterisks. So they are kind of similar. And this is fast in a Corasick. So I'm initializing the searcher. I need an array of matches. And then I'm going through all the matches that it finds. I'm getting the start and the end of the match. And then I have to make sure that there's no case where somebody writes 4 asterisks, which is possible, right? You can write that. That's not a new slide. And so to make that sure, I'm basically going into the bytes of this match, and going one further and just making sure that this is not an asterisk. And because if that's the case, I continue. Otherwise, I save the match and then I return these. So it's very simple, not complex code, but it's very fast because of that algorithm. And after that, I have all the strings of all the slide contents, and then I can parse them all concurrently, mostly, depending on how many cores you have. Now, not everything is well in Rust land. There were problems, and let me go through them. The first one is that I'm using Catalyst, and Catalyst is a different CPU target. And when I started, the Rust compiler didn't have support for that because they are not really focused on macOS and Apple stuff. And I waited for that, nothing happened, and so I had to add that support. So now I have actually contributed something to the Rust compiler because I needed that to continue with my app. That was not a nice experience because I'm not a compiler engineer. And then I'm using the C language and C API to bridge from Swift to Rust. That can lead to memory leaks, so I have to be extra careful here. And there were also multiple bugs in the Markdown parser and the syntax highlighter that I had to fix. The upside is I could fix it, right? With the Apple framework, you have to wait for the next year. I could just create a pull request. Going beyond Rust, something that was really important to me in this app is the typing performance. That was a major focus, and that alone cost at least 2 months. Because what I want is you type a character, that updates the Markdown, then the Markdown has to be parsed, then the text attributes have to be applied to the UI text view. Then the Swift UI slides have to be re-rendered, and then I have to update the UI because it might be that you entered a backtick, and now you're in a source, like in source code in the Markdown, and that requires a change in the UI. And all this has to be very fast. And the way it works now is all this happens below 10 milliseconds, even on old iPad Pros from 2016, and maybe even older iPads. I don't have any of those to test. I'm very happy with this result because it means you can type very fast. You don't feel a delay, and that's really good. Which brings me to the pathing problems, all the things that I ran into when doing this. There's a famous quote: "There are two hard problems in computer science: cache invalidation and naming things." And I certainly ran into the first one. Because when you insert a character into one of the earlier slides, then that changes the offsets of everything below that. So that means if you have like 100 slides and you insert one new character very much at the top, it would mean that I would need to re-render all the slides because the offsets are different, right? And I'm using these offsets to know to get the contents of the headline and so on, and to highlight the UI text view. So that's bad. And if I'm caching this, that's going to be very expensive because it's invalidating all the caches. And so I can't even do the rendering in a background thread because since SwiftUI is blocking, once I'm updating the slides on the right side, the UI would block. So if I would do the parsing of the Markdown in the background, that would mean that after you entered a character, like a couple of milliseconds later, suddenly the UI would be stuck. So that doesn't work. So it has to be so fast that doing it all on the main thread works fine. And the solution I have here is that I'm basically I'm doing eager parsing to not parse everything, only the absolute minimum, and then I'm remembering what also needs to be parsed. And once that is something that the user selects or works with, then I know what the last kind of mutation was, and I'm applying it. I'm mutating the attributes in the UI text view. That took a lot of time to get to work properly. Another problem I had was stable unique identifiers. So these slides, they don't have a key, they don't have an identifier. Like each slide just has an index, right? I don't have them in a database. It's just the Markdown. So if you insert a new slide at the very top, all the subsequent slides, they have a different index. So if I do caching here, I use the slide index, then basically the cache would be invalidated for all the slides because all the slides have different content now. So what I could do is I could do string comparisons. So I can take the contents of the slide and compare it to the content it was before for the other slides. But string comparisons in Swift are very slow. And I mean, usually in normal app lifecycle, you don't see that. But if you have like 100 kilobytes of text, which is not that unusual for a Markdown presentation, then that becomes very slow because this would happen for every key press. If you're interested in that and you don't want to use Rust, there's a video from the NS Spain 2019 from Eli Shin, no strings attached. They had a similar problem at Uber and they solved it in a different way. So what I'm doing instead is in the Rust area, I'm using a very fast hash called FMV hash to hash the contents of each slide. And I get I just get an integer back, and I can just compare that integer, which is very fast. So this is what I get back. I get back a slide. These are the elements, and this is the hash that is particularly based on the contents of the slide. That is very fast, and that allows me to not have cache invalidation if you insert a new slide. One complexifier that I ran into with the Rust thing and with this were indexes, because Objective-C uses UTF-16 indexes for their NS range type. And Rust, Swift, uses the Swift index, the range, is a index of a single extended grapheme cluster. And Rust uses UTF-8 byte indexes, which means when I get back from Rust the information about the offsets, the ranges where you find content, I have to convert it twice, once to Swift and once again to Objective-C, because they all use a different string index. That's expensive, kind of. So there's a bit of code. This is how you would do that. So first of all, you ask, the content is a string, it's the markdown string. You ask content for the UTF-8, which is a UTF-8 view on the contents, and UTF-8 is what I get back from Rust. And then from Rust, I get basically the start and the end of my range. And then I can ask Swift and say, okay, give me from the start index of this view, give me the index that is offset by start, which is what I get back from Rust. And then I can take this, do the same with the end index, and then I can create an actual Swift range out of this. So this is how you can do that. The problem is once you do that, this is really bad. It's bad in terms of performance, because what happens here is that when you do this, begin at the start index, and then offset by start, what Swift does is it starts at zero, and it walks up the whole string until it reaches the offset. If you have a huge string, again, 110 kilobytes, this takes quite a lot of time. And then you do it again here. So already twice you're iterating the whole string, which is especially difficult if there are lots of emoji and Unicode symbols in there. And that's expensive. So the way I'm doing it now is I'm remembering a begin index, which is the last index that I calculated. And then I'm starting at the begin index, offsetting from there. And Rust basically also knows this, so I'm getting different information back. I do the same for the end index, and then I return these, and the last end index here becomes the next begin index. So I don't have to recalculate the current position all the time. I'm just taking the last one and adding something on top, which makes it much faster. Now let's go to the UI side. I had a lot of problems with the software keyboard. That would be a nice talk, because on the iPad, the software keyboard can be in split screen, slide over, floating keyboard. You can have a keyboard in another app. Then you also have accessory views, and then you also have the suggestion bar. And each of these modify kind of how much of your UI is visible. And the API that Apple has here is very old and not really nice, because it relies on dictionaries with keys in there and some information, not type-safe at all. And one of the problems is that most people will use Hyperdeck with a keyboard attached. It doesn't make sense to build a wider presentation with the on-screen keyboard. Nevertheless, it has to work. And so I had to invest a lot of time, like 80% of the keyboard time, of the editing time, went into this, even though only 20% of the people will use it. That was not a nice thing to work on. As an example, this is the smallest the app can look like if you go to the minimum. And that is really and you still have to have a kind of good editing experience in that kind of screen. And that was difficult to pull off. And then we have Catalyst. I don't even know where to start. So first of all, you have the UI. And there, when you just take a stock iPad app, that doesn't really look nice on macOS. It looks pretty bland. And then you already need additional work to make it look nice. But you can't, because a lot of the things you want to do, they don't work. And so what you have to do then is you have to reach out to AppKit in order to add additional stuff that makes your app actually bearable. The way you do that, just as an information, because it's sad, is you add an AppKit bundle, which is basically using Cocoa frameworks and so on. You add that to your app, and then at runtime, you load that bundle. So you open it, you load it. Once it's loaded, then you can get the principal class back, and you're absolutely sure this is an NS object. And then you initialize it, and after that, you basically have your object, your basically whatever you defined in your AppKit bundle, and then you can call selectors on it, which is great. Also, quick note, when you do that, you might run into memory issues. So read the documentation for perform selector carefully. And that way I can call code on that and it works. Now, my actual implementation is a bit better than this, but this is the gist of how you do it. Which brings me to the catalyst crashes and bugs. This is for a particular problem that I have in the code here. You don't have to understand it. Please don't try to understand this code. So this is based on something that Peter Steinberger released, and I adapted it to my needs. But it took me 20 minutes to understand what Peter is doing there in order to be able to modify this. What it's doing is, on Catalyst, when you open a popover, the popover will always animate in with a very slow, terrible, janky animation, and you can't disable it. When you set the popover animated to none, it's completely being ignored. You always get these terrible animations. The only way to do that is here. I'm basically at runtime. I'm jizzling. I'm swizzling. So I'm overriding the set animates that is deep within Catalyst AppKit, and that's always set to true. And I'm basically setting it to false. And this is kind of how you do that. And there's a much better explanation by Peter. So if you're interested in that, ping me or Twitter on Twitter. He will thankfully point it out. It's just you have to go to these lengths in order to make your app work well on Catalyst. Talking about popovers, what you see here is a screenshot from the current macOS version of my app, and you can also see I currently have the current slides open, and you can see nicely that the popover is opened from a menu bar item, because these toolbars are new in Catalyst and they mostly work great. The problem is you can't use them for popovers. So the reason is that if you tap one of these toolbar items, I think they are called, they are Coco AppKit objects. And a popover always needs a source view. But you can't add a NS toolbar item to a popover as a source view, because this is an AppKit object. It doesn't know what to do with that. It just crashes at runtime. So there's no way to tap one of these and get a popover, because they are different walls. So how is it I'm displaying a popover there? What I'm doing is similar to something I a couple of days ago found at a different open source project. So I'm just displaying their code, because mine is a bit more difficult to understand. At runtime, they're figuring out where the NS toolbar item is, figuring out the rectangle, and then they're injecting a UI view into the view hierarchy, so that can be used as a source view for the popover, so that you can display the popover. Also, with the current release of Big Sur, this doesn't work anymore. If you use a UI view, you have to use a UI button. If you use a UI view in the current Big Sur, what happens is you get a popover, but it's not anchored to the button. It's just floating around. And it took me a while to figure out why. So all these things cost time. Another issue I ran into was that when you enter 3 dashes, then Catalyst would happily convert them into a hyphen. And that really is difficult in Markdown, because in Markdown 3 dashes signifies something like the table you see below, or like a slide separator. And on Catalyst, this would just be a hyphen. The Markdown was broken. There was no way to disable it. I opened a feedback report to Apple that was ignored for a year. And this year at DocDub, I managed to get a session with the developer, and now it's fixed in Big Sur. But it took a year. And this brings me to the gamble. Do I want to wait for Apple to fix many of these Catalyst issues that are everywhere? Or do I invest a lot of weeks to work around them, because I'm not hoping for them to fix them anyway? It's a tough call. And then you also have macOS updates that introduce new misbehaviors from time to time, which also brings me to cross-platform. It's not really cross-platform, because either macOS breaks iOS, so when you change something here, it breaks something there, or the other way around. And none of this is documented. There's lots of trial and error. So in hindsight, looking back, I should rather have gone with AppKit or UIKit, or share UI via SwiftUI, or maybe share controller and model code with Swift and Rust, or maybe use Flutter, but definitely not Catalyst. Which brings me to one thing I briefly want to talk about SwiftUI, because I started using that very early, and I see I'm a bit out of time, so I'm going to be a bit faster now. I'm talking about when you start with SwiftUI and you want to do layout, you have spaces, geometry, radius, and alignment. And then you get weird juggling and unexplainable behaviors. And preview was also difficult to get to work, and mostly it doesn't work anymore for me. And I also had to rewrite a lot of things along the way. And then you have tried to work around the inherent limitations. All that was very difficult. And I want to give one particular example of this. And that is what you see here. When you have too much content on a slide, then the content is out of bounds. But the problem is, how do I detect this? Because in SwiftUI, there's no did finish rendering. So I don't know when the rendering is finished in order to assess if the content is out of bounds. But even if they were, you don't get access to the SwiftUI views. So you can't just ask all the views, how high are you, and then know that they're out of bounds. Also doesn't work. And so you can't do the view frame, right? So this is difficult. So how to do that? The way I do this is, I'm basically trying to figure out what are the sizes of each the elements during the render loop and then adding them all up. That's the approach. And I will briefly show how I did that, like the lengths I had to go to. First of all, we have a slide view, very easy. This is like one slide. And in there is the slide elements view, which is basically a view that has multiple elements in there. So the slide elements view has a VStack with a spacing, and then it does a for each. And for each element, it opens an element view. So that's how you get a couple of elements below each other. Also, fairly easy. Now we get a new thing. We get an anchor preference with something called calculated slide size preference key. And then we get the bounds and the spacing. We'll get back to this because we want to ask ourselves, what is the anchor preference? Let's look at the Apple documentation. And this is what it says. No overview available. Nice. We already know what this is. Perfect. Thankfully, Swift with Majid comes in and tells us the main goal of anchor preferences is to pass layout data like bounds, center coordinates, etc. to its parent view. And this is what we want, right? We want in the slide to know the sizes of all its children. Great, what we want. In order to use these, we need a preference key. And this is, it's a lot of stuff, but what it basically is, this is a container for an array of something called anchor CGRect and CGFloat. That's the type. So this is basically an array of the bounds of all my children. Let's ignore the reduce here and so on. Let's continue. So what we want to do is we have the for each here with the elements view. We get the anchor preference. And then in our slide view, which is the one that houses all the slides, we have a geometry here that gives us the total geometry of the slide. And then we add this guy here, background preference, which is a thing on SwiftUI. I will come to that basically takes all these preferences, these bounds of all the children, and you can use that to create a new SwiftUI view. So here we are calling this one. I will go into this method, and we give it the geometry and the preferences. So we take all the bounds of all the children and are allowed to use this to create a new SwiftUI view. When we ask that, Apple says, use the specified preference value from the view to produce another view as a background to the first view. So this is the method. It's called display background. And what it does is it's calculating the height. So it's taking the zero height. It's going through all the child views, taking the bounds and the spacing and adding it to this calculated height. And then once this is done, I have a combined publisher that is debound. So that means it takes some time until it's triggering. And when you trigger it again, it will take a longer time. And if the calculated height is higher than the current presentation size height, then I know we are out of bounds, and then I'm saving it on a observable object so that everything will be noted. We are almost done because I need to return a view here, right? Because I'm supposed to create a background view here. And that's what I'm doing. I'm creating here a view. It's called Gaukel view. And you're wondering why not just an empty view? Because the problem is this code here is only going to be run if the display background changes. If the view you get back from here changes, Apple SwiftUI will rerun this. But we need it to rerun all the time. And the way I'm doing that is here. This is the Gaukel view, which is an equatable view that gets something called the render iteration. And whenever you enter a character into the app, I'm iterating this. I'm adding one to it. So this is always like with every change that happens anywhere in the Markdown, this one will be iterated and SwiftUI will re-render the background. And Gaukel, just for information, is German for to lead someone to believe something. SwiftUI believes there's a change, there isn't a change. Finally, if you put all that together, I can use that with the debounds here to have my publisher. Let's ignore this. This is a combined publisher that waits 400 milliseconds for a change. And then I have the size of the presentation, the out of bounds side, and I have the render iteration that can be added to. And with all of this, I'm able to figure out if there's something out of bounds in the slides. Like this. Yay, that was easy. So Apart from that, I had crashes when you use the trackpad cursor in SwiftUI with the hover attack. I had crashes on iPads from 2018 with input accessories view in SwiftUI. And I'm getting from my beta users a lot of SwiftUI layout system crashes, attribute failed to set an initial value. And the display link thing doesn't work in presenter mode. Only on the device after 3 seconds it crashes the device if you have SwiftUI in there. And there's lots of other things. I will not even read them out. These are things I ran into that were also difficult and took a lot of time. So the current status is the iOS version more or less works. The macOS version is still very rough around the edges. It only works on Big Sur. It's really, really hard to work on this in my spare time. I'm feeling exhausted. And you can see that here, this is my Git commit graph. And there was a long summer holiday that I took myself at the end because I needed a break from this project. I slowly started again, but I needed a break. If you think, man, I really would like more to listen to this German accented English, I have a podcast where you can listen to more of this, where I also frequently talk about problems I am having with Hyperdeck, with a thick, strong German accent. That's it. Do you have questions?
Yeah. Thank you, very impressive. Actually, it's really an engineer stuff. Like you think you spend too much time on creating slides, then you spend even more time writing an app to create slides, and you finally add support for Catalyst to the Rust compiler. Like that's the plan, right? So that was really impressive. But what would be, like, if you would start again today? What would be your ideal architecture for the app? Like, what technology would you use?
So I think I would try 3 different architectures as a prototype, each for 2 weeks. I would try AppKit and UIKit so that I have 2 targets, but I'm sharing a lot of code. I would try that, but I would also try Flutter to see how well that would work, to have something that is so across desktop that I could also in theory run it on Windows and so on. My biggest gripe would be that I didn't want to learn Dart, and I would need to learn a lot of new things, whereas with AppKit and UIKit, I still know what I'm doing. I wouldn't know that with Dart, so I would probably spend half a year relearning Dart. And so I guess I would go with AppKit and UIKit. That would be safe, but not with Catalyst.
Okay. If we have questions on the room, you can maybe raise your hand, and so we'll take your question.
Yes, I just wanted to add something that you have like a full-time job. You do this. You do lots of talks. Of course, you mentioned the contravariance. You also have adventures, so you do lots of stuff. Like it's impressive. And anyway. Was actually, in a way, your goal to see how many obstacles you would find down the road? Because I think you're not naive, so you in a way you figured that there are something that is still like rough around the edges. But was it your goal to go all through those obstacles, or you were a bit more optimistic at first?
So I certainly chose a lot of the technologies because I wanted to learn them. So SwiftUI was very new, and I thought learning SwiftUI would be very beneficial, and so that's why I chose that. With Catalyst, I did a gamble. I thought it would be much better than it is. So I was much more optimistic with Catalyst, and the Rust thing is also a mixed bag, but that is because of Catalyst. So in general, Rust worked out great. The problem is Rust and Catalyst is a very huge bag of pain. I didn't think that's something that I should have known before, but I didn't connect the dots. And so I did not expect that much work for Rust and Catalyst in combination. So there I was much more optimistic. But for SwiftUI, I did expect to go through this pain because it was a very good framework.
And what is your vision on the future of Catalyst? Do you think it's going to be did you really feel that it's improved a lot? Is it still a lot of work to do on that? Will it one day be a feasible or realistic solution?
I don't know how Apple is going about their things, but realistically, there's so much work that they still have to make this proper. And then on the other side, you have SwiftUI where the code works out of the box on all platforms automatically, and they are so focusing on that so much, right? I think at some point it would be good enough for what Apple is doing with Catalyst, that's it. And it will just stay that way. It might be with iPad apps on ARM that they are going to get an additional investment from Apple because a lot of people are using that, but that depends on how many companies will actually allow their iPad app to run on ARM. If not many companies do that, then there's no incentive for Apple to go and update Catalyst even more. So I think it a bit depends also on that.
Actually, how many routers did you file?
Only, and this is kind of sad, only 7 or 8. I do have a huge list of things I want to file. But the problem is that it's always, we know that we have to file the radars, otherwise they don't know about that. But all the radars are filed were ignored, except for the one where I got a meeting with the engineer that worked on Catalyst. And he was very surprised to learn about the radar that had been open for 1 year. And that kind of demotivated me, to be honest. I still have a list. I still want to take the time to file all these radars. But oftentimes, if you have a big app with a lot of complexity, sometimes I'm trying to create a sample project, and there it works fine. So then I need to figure out what is it, like how much of the stuff I wrote do I need to add in order to have an example. And I don't have the time really, because my main focus is to get the ZEP finally done, and I have to cut corners everywhere. And radars is one thing where I cut corners, because adding 1 hour to a radar is 1 hour where I could actually fix bugs.
Yeah, super interesting. Do you have any questions from the audience? Oh, okay. So thank you very much, Benedikt. It was very, very interesting.